Okay, hey everyone. This is the third video in our Top Interview 150 Leetcode playlist. And in this video, we are going to solve the third problem in the list. And the name of the problem is remove duplicates from sorted array. It's an easy problem. So let's get started. So given an integer array num sorted in non-decreasing order, remove the duplicates in place. We have to remove the duplicate elements in a sorted array in place, okay, which means we cannot use extra space, such that each unique element appears only once. Mhm. The relative order of elements should be kept the same. Then return the number of unique elements in nums. Okay, so we have to return the number of unique element in nums, and at the same time, we also have to remove the duplicates in place. So basically, what they are asking is, if we have been given an array where it's one which is sorted, what they want us to return is 2 because we have two unique elements, and the array should look like this at the end of the solution. Now notice that in this question it says since we have to do some in place operations on this array, so we don't care about what elements are stored in this part of the array after the solution has been executed. We only care about the unique element, and they should be on the front of the array. Okay, now in order to achieve this, what we can do is we can keep iterating on the array, and for every element we see if this element is repeating or not. The way we can check is we can just compare it with the next element, and if they are same, which means this element is repeating. Now until this element is repeating, we keep going forward in the array till the last occurrence of this element, and then what we do is we copy this element to the first occurrence of that element. And then what we need to do is we also have to maintain a start pointer, which will be always be pointing at the beginning of the array. And every time we find that we have processed a specific element which was repeating, we basically copy it to the index of the start pointer and move the start pointer to the right. So let's code this. As I explained, we will be needing two pointers. We need a start pointer, so keep a start pointer to copy result to the beginning of the array, and keep a moving pointer to scan the array. Okay, so let's say our start pointer is start and our moving pointer is ptr. Initially they are both set to 0. Now for every element in the array, we scan the array forward and see if the element is repeating. If it is, we keep moving forward until the last occurrence of the element. And finally, we copy this element at the start pointer and move the start pointer to the right by 1 unit. So we start scanning while pointer is less than equal to nums dot length minus 1, and for every element we want to move forward until it is repeating. So while nums of ptr is equal to nums of ptr plus 1, we keep moving forward. So we say ptr plus plus, and then after we have found or went over all the repeating occurrences of the same element, we copy the value in nums of start with whatever the value of ptr is. Okay, and then we have to also move the start pointer ahead and the ptr pointer, which is the scan pointer, ahead as well. Now after the entire array has been scanned, if you see in the question, we have to return the number of unique elements in nums. So here the number of unique elements was 2, and you will see that after processing this array, in the output, start pointer will always be at the index, which is equal to the number of unique elements in the array. So here the start pointer is at index 2. So we have 2 unique elements in the array. So for the answer, we can just return start. Now, one corner case in this question is that when you are scanning for repetitive elements, there might be a case where all the elements are repeating and you will go towards the end of the array, and this might throw a index out of bound exception. So in order to stop that, what we do is we only keep checking for ptr plus 1 until ptr is less than nums.length minus 1. So we never go beyond the boundary of the array. Now let's try to run this code, and we see that it passes all the test cases. Let's try to submit it, and our code is accepted. So thank you for watching, everyone, and in the next video we will be solving the fourth problem from this list.